With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. The figure shows a block P of mass m resting on a smooth floor at a distance L from a rigid wall. Block is pushed toward right by 3L by 2 and released. When the block passes from the mean position, another block of mass m1 is dropped over it. Find the minimum value of m1 so that the combined block just collide with the left wall. So what will happen? When you will compress it by a distance 3L by 4, right? What will happen? The spring will get potential energy, right? What will be the potential energy if I compress this spring by 3L by 2? So it is simply, I will write down the potential energy at this position. If I say this as initial position, it is simply half K compression in the spring whole square. So X is 3L by 2, so it will be 3L square by 4. So it will be 4 into 2. So it is 9 by 8 KL square. This is the spring energy stored in the spring in the form of potential energy, right? Now what will happen? When I will leave this in that situation, the spring will apply the force on the block and they will shift toward left, and we want to hit this to the left wall, right? In between the situation, a small block of mass m1 is kept over it. If you see, when the block was passing from the mean position, another block of mass m is dropped over it. So this is not kept here, so it is kept at the mean position, at this position, when it was passing through it, right? So if I say this position as position 1, position 2 and position 3, right? There are 3 positions after compressing the spring by 3L by 2 and then leaving it. The first initial position, then the natural length position 2, this is the natural length. Then it is 3 position. So when the block, this M block, will be at the natural length, the kinetic energy will be 0. So if I say this potential energy as potential energy at position 1, so here the mechanical energy will remain conserved for this journey, right? So I will write down kinetic as and potential at position 1 is equals to kinetic plus potential at position 2 from the mechanical energy conservation. So if you see here at position 2, you can see the spring is at natural length, and at position 1 it was released. So the position at position 2, the kinetic energy will be same as that of the potential energy at position 1, that was this. Now what happened? A mass m1 is kept over it, right? So what will happen? The momentum will remain conserved. If I talk about the momentum of this system, it will remain conserved. So whatever momentum it was having, it will remain the same, right? So let's say it was moving with velocity v, right? It was moving with velocity v, then momentum before keeping the m1 mass was this. So this momentum will remain conserved, right? So if I write down, after keeping the mass m2, after putting m2, the kinetic energy k2 dash, it will be p square by 2. Now the mass changed here, right? Mass is now m plus m1, right? So mass changed here. So if I write down the momentum, we know that it is nothing but k, where k is the initial kinetic energy, right? So it will be 2m, k is this, under root 2mk is the momentum, right? So you can put the square of it, right? It will be 9 by 8. So this 2 and 2 will get cancelled out. 9 by 8 KL square, right? And here I will write down this is m mass. It is m by m. So this is the kinetic energy after keeping the m1 mass on it, right? It will be just multiplied by this m by m1, m by m plus m1, right? Now we can conserve the energy from position 2 to 3 now, right? So I will write down the changed kinetic energy at position 2. Position 2 is the equilibrium, is the mean position, so there the potential energy is obviously 0, kinetic energy at 3 and potential at 3. So it is already given that it just reaches to 3, so it will be 0. So K2 we already calculated, it is 9 by 8 KL square m upon is equals to the potential energy at third position is, extension is L here. If you see, the extension is at the third position is this much. So we will write this. So KL square can be cancelled out. Now you can cross multiply 8 m1. So it will be 10 m. So we want this m1 is 5 by 4 m. And this is the answer of this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.